Hello friends, welcome to another session on Quant. What we do here, and if you are coming to this channel for the first time, what we do here is talk about the quant topics that are highly relevant for your any entrance MBA exam in India, be it CAT, INMAT, SNAP, IFT, ZAT. So whatever wherever we go, these topics are very relevant, and we cover those topics in pretty detailed. So if you have seen, we typically follow a three-stage approach for any topic, or three-session approach. So the first session is on fundamentals. The second session is going to be on problem session one, which is more of a foundational level or basic level problem, which helps you strengthen your concepts, understand what is the thing that we learned in fundamental and how that can be translated and applied into a problem. What are the different type of problems that can come? And in the third session or problem session two is basically focus on advanced or level three or level two level problems. So that's where we typically focus on those little complex, little tricky, a little calculation intensive kind of problem where you need to know certain exception, certain variation, a certain deviation, or certain extra correlation between what has been already taught in the fundamental class, and that can be applied there. So these are the three levels that we follow. So today we are going to talk about one of the topic that's very relevant for your CAT you or any entrance exam, MBA entrance exam. If you see, typically around 2 to 3 problems you can get this in CAT. So this topic is on just a minute. So this topic is graph. So basically when it comes to algebra, um, graph is by far the most important chapter, or you need to, because this is there is no formula as such you need to remember, but there are certain concepts, or there are certain foundation level understanding or basic understanding that you need to have complete clarity on how a graph is drawn and how the graph looks like, so that you understand the code of it, and then you can apply. You can't remember all the type of graph always. You just need to understand how a graph should look like and what are the points that you need to think when you are trying to form a graph, and that's how you should be approaching this chapter. So okay, without further ado, let's get started. So what we know in typically a graph is basically, so the graph of what we know, it's a geometrical representation. So basically, if I say y equal to x plus 5, so this is basically a graph of a straight line. So in a uh, x and y axis, so this is x, this is y. A graph basically represents a straight line. So how will you draw the straight line? So let's say if I put y and x. So if x is 0, y will be 5. If y is 0, x will be minus 5. So these are the two things I know. So if x is 0, that means it's here. Y will be 5, so that means let's say here. And if x is 0, y is 5. If y is 0, x is minus 5. So that means somewhere here. So if I know 2 points, I can easily draw a graph between these 2 points. So this is the line of y equal to x plus 5. So this is the graph of y equal to x plus 5, right? This we know. We also heard, if you have not gone through the quadratic equation class or linear equation class, you can see the algebra playlist that I will put in the description box, and from there you'll be understanding very differently how this linear equation or a quadratic equation that I'm going to show is typically drawn. So y equal to, let's say, x squared. So I know when x is 0, y will be 0. When x is 2, y will be 4. So, and the coefficient with x is 1, which is a positive number. So the graph will be moving upwards or something like this. So this things we know already from the quadratic equation and the linear equation class, that if y equal to minus x square, or the coefficient with x is minus 1 or a negative number, then it's typically open downwards. So really open downwards. So these are the foundational things that we have learned. So what we do today is, if you recall the previous class, what we talk about inequality and modulus, and again you find that in the algebra. So the inequality and modulus class we talk about in detail around modulus. So we'll focus on the graphs which have a modulus. So a quick recap: what is a mod? Mod is basically distance of a particular point from another point. So if I say x, mod of x, so distance of x from 0. If I say mod of x minus a, then it is distance of x from a. So since it's distance, it cannot be negative, right? So if I write y equal to mod x, so that means x can be greater than 0 or x can be less than 0. But in both these cases, y has to be greater than 0. So this equation will boils down to y. So if x equal to 0, then also y is equal to x. If x is minus x is negative also, then also that will be equal to y. So if I say, let's say my x is 5, my x is 5. So if I say x is 5, then y is also 5. So that means if x is 5 and y is also 5, this will be the point. If x is minus 5, then also y will be 5, because x is a modulus. So modulus of minus 5 is 5. So this is also a point, right? And we also know y, when x is 0, y is also 0. So this is also a point. So it will be like this. So basically what I'm trying to say is, if x is greater than 0, so this part, and this part is x is less than 0, both the way y is positive, because this is the y positive zone. This part above x-axis, it's basically a y positive zone. So x is greater than 0 or less than 0, y will always be positive, right? And so if x is minus 1, y will be 1. If x is minus 2, y will be 2. So y equal to mod x. How your graph will look like? Your graph will look like this. So this has to be the origin. Okay. So this is the graph of y equal to mod x, right? Now let's do a little variation. So if I say y equal to mod x plus 3, what will happen? Y equal to mod x plus 3. So if I say now my x is 3, y will be 6. See, mod x is always going to be greater than 0. If it is greater than 0, I can say y is always going to be greater than 3. So y cannot be negative. So even if I have x equal to 0, I will have y equal to 3. So that means my graph for y equal to mod x, it was like this. This is for y equal to mod x. So mod of x plus 3, it will go up by 3 unit, because here when x0, y0, but here when x0, y3, right? So this same graph will shift out upwards, right? So this is equal to y equal to mod x plus 3, right? And this is 0, 3, right? Similarly, if I tell me the graph y equal to mod x minus 3. So mod x minus 3, so this is the graph of y equal to x. So here, if x is 3, y will be 0. If x is 0, y will be minus 3. So if I draw this graph, x is 3 and then y is 0. So this must be a point. Similarly, when x is minus 3 also, y will be 0, because mod of minus 3 is 3. And similarly, when x is 0, y is minus 3. So this graph, down to this. So if you see the graph y equal to mod x minus 3. So basically, if you see y equal to mod x goes up by 3 unit if it is mod x plus 3, goes down by 3 unit if it is mod x minus 3. Similarly, if we say y equal to mod x plus 3, so here if x is 0, then y will be 3. If x is minus 3, y will be 0, right? So if I draw the graph, x is 0, 3, x is 3, so this will go like this. So here 3 comma 0. You can see this is not the right thing, so this will go more like this. Okay, so this is the graph of y equal to mod x plus 3. Similarly, what will be the graph of y equal to mod x minus 3? So see the graph, it will typically go towards the right. This will be 3 comma 0. So what we understood, if we summarize, so if we summarize what we understood, y equal to mod x is one graph, y equal to mod x plus a, y equal to mod x minus a. These are the three type. First, let's see what are these three graph. So these three graph, this is going to be going to the center when it is mod x plus a. When it is mod x plus a, it is going towards the left by a unit. So this same graph will be shifted more towards the left by a unit. This one, it will be shifted towards the right by a unit. So this will be a comma 0. Right? So if we see the same graph here will shift towards the left if it is mod x plus a, shift towards the right if it is mod x minus a. And similarly, if we have y equal to mod x plus a, then also this same graph will go up by a unit, so 0 comma a. And if we have y equal to mod x minus a, then also the same graph will come down by a unit or comma 0 comma minus a. So these are the 5 times which is very, very important when it comes to your understanding of how modulus of a graph typically behaves. So mod of x plus a, mod of x minus a, and how this will behave. Mod x plus mod y equal to 1. This is one type. Let's say mod x minus mod y equal to 1. This is another type. Say mod y minus mod x equal to 1. That is another type. There are 3 type of problem or 3 type of graph we will see now. So let's start with this first one. So mod x plus mod y is equal to 1. Now mod x plus mod y equal to 1. There are 3, or let's say there are 4 possible scenario when x is positive. Then for that y can be positive or y can be negative. Similarly, the same thing is possible when x is negative. Y can be positive, y can be negative. So when x and y both are positive, x plus y will be equal to 1. When x and y both are negative, then it will be x minus y equal to 1. Then, sorry, x positive, y negative, x minus y equal to 1. If x is negative and y is positive, then this will be equal to 1. And when both x and y are negative, then also this will be equal to 1. So these are the 4 scenarios that is typically possible, right? Okay. Now, if you see carefully, if you see very carefully, what it says is the first one says x is 0, and so there is a possibility in the first one, x is 0 and y is 1. X is 0, y is 1. Similarly, when x is 1, y will be 0 in the first case. So first line will be like this, which we say x plus y equal to 1. What will be the second line? The second line will be, we can say x minus y equal to 1. So here when x is 1, y is 0, x is 1, y is 0. So this will go through this graph, this line for sure. Similarly, we can say when x is 0, y is minus 1. When x is 0 in the second equation, this equation, when x is 0, y is minus 1. That means it will go through here. This will be the graph of x minus y equal to 1. Similarly, minus x plus y equal to 1, if I consider this, then when x is 0, y is 1. When x is 0, y is 1. When x is minus 1, I'll say y is 0. X is minus 1, then minus of x will become 1, and then y becomes 0. This will be the graph. So this will be the graph of minus x plus y equal to 1. Similarly, if you see in this case, if you take this, then from here we can say, okay, when x is 0, y is minus 1. When x is 0, y is minus 1. And when x is minus 1, y will be 0. This graph will go along this line. So this is 0 comma minus 1. This is 1 comma 0. This is 0 comma 1. This is minus 1 comma 0. These are the 4 points, and the 4 graphs will, 4 lines will go through this. This is what? So this is what your the mod x plus mod y equal to 1 will look like, right? Mod x plus mod y equal to 1 will look like. So if I just delete all this, rub all this, so then we can say this let's see this going to the same point. Yes. So if I see typically, what is the mod x plus mod y equal to 1 solution? This is going to be this. And this is 1 comma 0, 0 comma 1, 0 comma minus 1, minus 1 comma 0. So these are the modulus of x, right? And what was the actual one earlier? So this goes through this, goes through this, through this. Okay, so this from here we can derive what was modulus a x plus modulus of y equal to 1, right? Now, if you have modulus of x minus modulus of y equal to 1, how will you draw? So what is modulus of x? So here, since the difference is equal to 1, mod x always has to be greater than equal to 1. So x will always be greater than equal to 1. Now x can be positive, or x can be 2, or x can be negative, or x can be minus 2. But modulus of x will always be greater than 1. So this region, this region, and this region where mod x is greater than 1, because this point is 1 comma 0 and minus 1 comma 0, this point and this point. So modulus of x minus modulus of y will always be less than modulus of x. So it is going to be, the graph is going to be like this. This is 1 comma 0, this is 0, sorry, minus 1 comma 0. Okay, so this is what is going to be. Similarly, in this scenario, modulus of y has to be greater than equal to 1 and modulus of x has to be less than equal to y. So in the same graph, we can say this is going to be the line zone, which is modulus of y has to be greater than equal to 1. So it can be 2 or it can be minus 5. But the modulus of y has to be more than 1. So 2 or minus 5, it has to be more than 1. So y cannot be less than 1. So from this, we can say the graph of this will be this. This is 0, comma 1. This is 0, comma minus 1. Right? So these are the graphs of modulus of y minus x equal to 1. So this is the graph. Mod x minus mod y equal to 1. So this is the graph. And this is the graph for modulus of x plus modulus of y equal to 1. So you understood this, right? So when mod x is more than mod y, mod x minus mod y equal to 1, your graph expands towards the x-axis, and mod y minus mod x equal to 1, where mod y has to be more than 1, the graph will go up and down of y-axis. So mod x more, it will go towards the both the sides horizontally. Mod y more than 1, it will go top and bottom more than 1. So that is the change of this. So we understood this, like the previous one, we talk about what are the different scenarios of y equal to mod x and how the base graph. So let's say this is the base graph is going to change when we do plus a minus a, outside modulus plus a minus a, all the four scenarios. And in this case, this is my base graph. This is my base graph, and how it is going to be shifted when it's come to mod x minus mod y equal to 1, mod y minus mod x equal to 1. The one other important factor is, so when I say mod x plus mod y equal to 1, and you have the graph like this, this is 1 comma 0, 0 comma 1, minus 1 comma 0, 0 comma minus 1. So if this is the graph, and now we can say what is the geometrical figure of this. So this is a rhombus. Okay, so the area, you can say half into multiplication of the diagonals. So these are the two diagonals. What are the length of two diagonals? From 1 to minus 1, it is 2 here, and 1 to minus 1, it is 2 here. So half into 4, or 2 squares, 2 square unit. Right? So this is the area. So how we can see? So this is the intersection point, and what is the intersection point? It is x minus 0 plus mod y minus 0. So in this case, these zeros typically denotes the intersection point of the diagonal. And so if I have to generalize this, so if something is mod x minus a plus mod of y minus a equal to k, then typically I will say a comma a is my intersection point, and what was 1 there, now it is k. So a comma a is my intersection point. So in this case, if a is positive, so I can say a comma a, this is going to be my intersection point, and the graph will be, then this is going to be my intersection point, and this is k. So if you see this distance will be k. So like this distance was 1, so this distance will be k. So that means this distance will also be k. So your area always be half into k square, or k square by 2, right? sorry, 2k whole square. Sorry, not k, my bad. Half into 2k whole square, or 4k square by 2, or 2k square. So this is going to be your area always. So because this is k, so the distance is 2k. This is k, this is k, so the distance is 2k, right? Uh, so let's take a small example. Let's say I say mod of x minus 3 plus mod of y plus 5 is equal to 10, right? So my intersection point will be 3 comma minus 5. 3 comma minus 5 will be my intersection point. Now, if I see here, this is 3, and let's say this is minus 5. So this is my intersection point. Now, if this is my intersection point, my graph will look something like this. From the intersection point, this distance will be 10, and this distance will be 10, this will be 10, and this will be 10. So my area, this point will be 3 comma minus 5. So my area will be half into 10 square, or 50 square unit, right? So this is the normal way you try to capture the problems. Now, what if they say instead of this, we remove, instead of this, and they say is what if mod x minus 3 plus mod y minus plus 5, sorry, minus mod y plus 5 is equal to 10. So now you can understand there is, so how the graph will look like. So the graph will look like, if we say, you can say here, the graph will somewhere, so x minus 3, so it will go 3 unit to the right, and y plus 5, so it will go 3 unit to the top. So the graph will look like more of this. The graph is looks like this, where there is no enclosed area. Your area will be infinite, right? Your area will typically be infinite. Now, what is another important thing that you may not have seen in the previous problem? So when the graph is not enclosed, your area is always infinite. That is understood. And x mod x minus mod y, your area under that is infinite. But mod y minus mod x is also infinite. What I think I kind of need to cover in the previous graph that we have drawn is, so how we draw mod x minus mod 3 plus mod y minus mod 5 is equal to 10. Let's say this. So here your intersection points are 3 and 5, right? So in a graph, this is, let's say 3, and let's say this is 5. So this is 3 comma 5. And so this is your intersection point, and the graph will look like this. Graph will look like this. So if you see the graph of mod x plus mod y equal to 1, this was my base graph. This is mod x plus mod y equal to 1. If this is my base graph, what has happened to here? So the graph has been shifted to the right by 3 unit. So if you remember, if y equal to mod x, and then if you have y equal to mod x minus 3, what happens? What I covered, your graph will be shifted to the right. So the graph has been, this graph has been shifted to the right by 3 unit. And then there is a sum of y minus 5. Y minus 5 means the graph will typically be upward or downward. So if I say y equal to mod x, how the graph of y equal to mod x minus 5 will look like? how the graph of y equal to mod x minus 5 will look like. So if x is 0 here, y is 0. If x is 0 here, y is 5. So that means the graph will go up, right? So if I go back to this one, where is this? Yeah, this one. See, this one. See here, mod x plus a. What happens? It shifted to the left. Mod x minus a. What happened? It shifted to the right. Mod x minus a shifted to the right. Mod x plus a shifted to the left, right? So similarly, what I have here is, so mod x minus 3, then that means it has shifted to the right. For y, y equal to mod y minus 5, that means this part, the top part will also shift it to the right. So this overall graph, so overall graph, if you think this is shifted to the right and then this is to the top. So that's where it's basically coming from, y equal to mod x minus 3, mod x minus 5. So 3 and 5 will be your center zone. So the graph will be first shifted to the right. So this graph will be shifted to the right and then towards the top. So this way you can understand how these two will behave. But again, the basic idea is try to find the intersection point and know the nature of the graph. If it is mod x plus mod y or mod x minus mod y or mod y minus mod x. So then from there you can do this. Okay. Now the last part before we wrap today's session is basically talk about some of the important graphs. So before that, what we need to understand is, so let's say there is something called as a odd and even function. So what is odd and even function? So odd function says odd and even function. So if I say f of x is equal to x, then if I say f of minus x is also equal to x, then this is the case of an even function, right? I'll give you an example. Let's say y equal to x square, or not y, this matter. Let's say f of x is equal to x square. Both are actually same. We can consider this as y only. Of x equal to x square. So if we put f of 2, this is 4. If I put f of minus 2 also, this is 4, right? Because x square is 2 square or minus 2 square, both will be 4. So now in this case, we see the graph of fx equal to x square is basically like this. So it's symmetrical around the axis. So this is called as symmetrical around the axis. So similarly, if I know if x is mod x, that means f of x is also x, f of minus x is also mod x. So mod of x will be again an even function. So f of minus x is also mod x. F of x is also mod x, right? So this is a function. So y equal to mod x, what is the graph? This is also again symmetrical towards the around the axis. So both are same. So if it is an even function, it is has to be symmetrical around the axis, be it x-axis or be it y-axis. Now, what is an odd function? The odd function says f of x is x, but f of minus x is minus x. Think of this as a y equal to x. So this is fx. Now, if I say f of minus x, this is going to be minus x. Now, see the line of y equal to x, y equal to x. So it's not symmetrical around one axis, it's symmetrical around origin. So this is, so origin, say, up and down. So it's symmetrical around origin. Similarly, if I have fx equal to x cube, which is again an odd function because f of x is x cube, f of minus x is minus x cube. So in that case also, this will be like this. So again, symmetrical around origin, right? So this is the one part of a even function. This will be symmetrical around the axis. Odd function symmetrical around origin. Now the last part that we are going to cover is the logarithm. Let's say there is a fx equal to log x, log of x base e. Now one thing you need to remember is log of x base e, x has to be greater than 0 or greater than or equal to 0. You can say x cannot be negative when it is a part of log x. So log of x base e, this can be, this is less than 0 if this is less than 0 or less than, we can say equal to 0 when x if 0 then equal to x is then equal to 1, right? So less than equal to 0. Is less than equal to 0, log of x base e is always greater than 1 if x is greater than 1, right? Between 0 to 1, log of x base e is going to be negative, and when x is greater than 1, log of x base e will be greater than 0, so positive. So what if I draw a graph of fx log of x base e? So the graph of log of x base e goes like this. So this is the point where x is equal to 1 and log of 1 is equal to 0. So this is the point of log. So this is the graph of y equal to log of x base e, right? Similarly, if I say y equal to e to the power x, when x is 0, y is 1, e to the power 0 is 1. So this will go like this. So this is y equal to e to the power x. Very, very important graph. Try to understand what is the graph of log of x base e, log of e to the power x. So e to the power x is an exponential. So if x can be negative here, it's when like log x cannot be negative, but that is not the scenario. And log of x can be positive or negative. So log of x base e is basically y in the previous section. So this part, this whole part can be negative, but x cannot be negative. So this whole part can be y. So then we can say y can be negative after x falls less than 0 or x falls less than 1. X cannot be 0. So x falls less than 1 is basically, or log 0 you can say is 1, which is not a very standard way of saying it, but this is what you can think of. So it tends towards 0. Now you can say y equal to modulo e to the power x, where x is 0, y is 1, but x can be negative, and that's why it is something like this, right? Okay. Now, what are the other different scenarios that we will see now? So there is a scenario where we can say y is equal to log of mod x base e. And how you think will the graph looks like? Since it's mod x, now x can take both positive and negative, and it will give you the same value. This is the one graph. This is the other graph. This is 1, 0. This is 0, sorry, minus 1 comma 0. It's minus 1 comma 0. Because now x has a modulus, x can take both positive and negative. That's how it is to be look like. But what if I write y equal to log of x plus e whole modulus? Whole modulus means y cannot be negative, and since x does not have a modulus here, x also cannot be negative. So this graph will come till here, and for all the negative values, all the negative values of x, it is going to be all the negative values of x, it will not satisfy. So y cannot be negative overall. So between 0 to 1 of, so this is 1 comma 0, right? So between 0 to 1, for more than 1, this will follow this path. Between 0 to 1, it was ideally like this. If the whole modulus was not there, because y becomes negative, but here y cannot become negative. So x value between 0 to 1, it will start going ulta or up. So instead of going down, it will start going up, because your as a whole y can never be negative. So between 0 to 1 of x, y was negative earlier, but so if you see this graph, between 0 to 1 of x, y was negative, it was coming down. So this will not be negative, it will start going up, it will start going up. So that's what we have done in this case, right? So this is one. Let's say the other one, let's say y equal to log of mod x mod e. So how you are going to draw this? So if I going to draw this, then it's the same way, because now x can take both positive and negative, but as a whole y can never be negative. So it will come here, go up, similarly it will come here and go up. So this is 1 comma 0, this is minus 1 comma 0, not straight line as a whole. So in the previous one we saw, here in this case both of them are coming down, both of them are coming down here and here. And if I put a whole modulus here, it will start going up, right? Between 0 to 1 and 0 to minus 1, y will start going up, right? Now let's say there is another one, y equal to log of e, and then you have, sorry, then you have minus x. So if you have this, how you are going to draw? So if this is the case, then the only possibility is going to be this. Because x can only be negative, because as a whole this part cannot be negative. But if I put x as positive, now it will become negative. So x can only take negative value here, right? This is an important one. Now I will try to cover one more. Let's say y equal to minus log of x base e, minus log of x base e, right? So in this case, between 0 to 1, when y was negative, y will actually be positive. Between 0 to 1, when y was negative of x, between x 0 to 1, y was negative earlier, now it is going to be positive. Between above 1, it x value more than 1, y was always positive. If this was not there, if minus sign was not there, between 1 and above, y was always positive. Now it will become negative. Right? So understand how we are drawing this. We are not memorizing this. We are just applying certain logic and try to draw the graph. We know the base graph of y equal to log of x base e, and we are doing this. Okay. Now to summarize things quickly. So there we know. Now to summarize things quickly, okay, let's go to the next one. We have y equal to log of x base e. So this is the base graph, right? This is at 1 comma 0. Then we have y equal to log of mod x base e. which is basically the graph coming from both the sides. Then we have typically log of mod x this e whole modulus. Oh, we have one more, will come there, but if both of them are as a whole modulus, then we have typically this going top, this come here, go top. If we have y equal to log of x base e whole modulus, then the graph is going down and going up, right? So this is one. And we have also see y equal to log of minus x base e. In that case, x has to be negative. X has to be negative, and between 0 to 1, between 0 to 1, y will be also negative. This is the case, and the final one we did log of x base e negative value. So in that case, this will go like this. These are the 5-6 type of different type of log x graph, and you understood how each of these are getting formed.